Hello, my ninja warriors. Welcome to yet another power-packed session. And in today's session, we are going to discuss most likely or most repeated questions from the chapter Relations and Functions for your upcoming PU board examination. Let me be very clear about it. This is not about KCET. KCET sessions are separate session, different session. This session is specifically for your second PU Karnataka board. Okay. So let's quickly start today's session. But before I start, I just want one green signal from you that ma'am, you're perfectly audible and you're perfectly visible. Okay. So that we can quickly start today's session. That is number 1 point. Number 2 point, you all know what you have to do. The moment you join the session, you have to like and share the session with your fellow Karnataka board aspirants, right? Okay. All right. Yes. So let me give me a green signal. Vedika, hi Anoop, hi Pradeep, hi Rohan, hi Kush Mohit, hi Indumati. I can see you guys after so long, right? We are taking this live session after quite a long time. How are you guys? First of all, tell me. How are you? Okay. And okay, you guys are not helping me out, huh? Am I audible? Yes. Vedika gave me a green signal that ma'am is completely all right, audible and visible, absolutely live. So now most repeated questions from relations and functions I have taken. So you know what is the paper pattern of your board examination. You will have 1 mark question, you will have 2 marker question, you will have 3 marker question, then you will have 5 marker question, right? So what we are going to do is we are going to start with 1 marker question and then gradually we'll talk about 3 marker, 5 marker as well. Okay. All right. Okay. I can see Sejal as well. I can see Rohan. I am absolutely fine. Okay. All right. So let us quickly start with the first question, which is a 1 marker question, guys. And actually before question, let me just give you a brief. So I just want to give you a brief about what is an equivalence relation. So basically we will talk about types of relation first. Types of relations. Okay. So types of relations. And also, this is going to be important for your KCET as well because your syllabus is same. The basics are almost same, right? So the very first is reflexive relation. Are you able to recall what is a reflexive relation? Are you able to recall what is a reflexive relation? So suppose a relation is defined on set A. So suppose an R is a relation, so which is defined on set A, and A comma A should belong to your relation R for all values of A belongs to set A. Now understand, if your relation is defined on set A, that means a set A is given to you. Okay. And now all the elements, suppose set A is given as 1, 2, 3. Now your R relation should have 1, 1, 2, 2 and 3, 3, all 3 ordered pair. If it is happening, then we will call it as a reflexive. Otherwise, we will not call it as a reflexive relation. I hope this is fine. Now, what about ma'am? Symmetric relation. Symmetric relation, I will say that if A comma B is belonging to your relation R, then that simply means that B comma A should also belong to R. If it is the case, then only we will call that relation as a symmetric relation. Okay. Third, transitive relation, right? Transitive relation. Now, transitive relation sometimes may get a little bit tricky. So, this is something which you should understand and practice very carefully and nicely. Okay. Transitive relation says if your A comma B and B comma C, these 2 ordered pairs are present in your relation, then A comma B, B comma C, that means the second element and the first element of both the ordered pairs should be same. Then you should check for A comma C. It should be belonging to R. If not, then we will not call it as a transitive relation. Okay. I hope that all the three types are clear to you, and if they are clear, I can jump on directly to the question, which is this, which is talking about this relation. This is a 1 marker question, and I would like you to solve it before even I just attempt it. Okay. All right. Yes. So relation in the set 1, 2, 3 given by this. Now they are asking whether it is symmetric, whether it is reflexive or not. Now understand, for this relation to be reflexive, if you want this relation to be reflexive, you want 3 ordered pair inside it. What are those 3 ordered pairs? 1, 1, 2, 2 and 3, 3. You all 3 ordered pairs should be residing inside your relation. By the way, this is your relation. Hold on. I can't see any of these ordered pairs. So definitely it is not reflexive, guys. Okay. Alright. Now what about symmetric? Symmetric means that if 1, 2 is there, 2, 1 should be there. If 2, 1 is there, 1, 2 is there. That means reflexive, definitely it is satisfying. So reflexive is there. But what about transitive, ma'am? Transitive may understand. If I check transitive, na? So if 1, 2 and 2, 1 is there. See, 1, 2, 2, 1 is there. So 1, 1 should also be there. But it is not there. This is not true. Not true means it is not transitive. So it is not transitive. Now, any relation which is all 3, reflexive as well as transitive as well as symmetric, then only we will call it as a equivalence relation. So equivalence relation means reflexive as well as symmetric as well as transitive. So clearly my relation is neither reflexive nor transitive. So that is why option D is also wrong. Only option which is correct is symmetric. What a good start for this session. Okay. So I guess we have on the very good note, I have done this question. Now the next 1 marker question we have over here, which says that there is a function which is defined as fx equals to x raised to power 4. Now understand, see, since this is a 1 marker question, nobody is going to talk about how are you solving it. Okay, you can solve it, like you can even just solve it in your brain, verbal. Okay, you can do this because this is an MCQ, right? Fx equals to x raised to power 4. Now we need to know whether your function is 1, 1 and on 2, many 1 on 2, 1, 1 but murder. Okay, like that. Okay, so the very first thing we will check for 1, 1. You know what is a 1, 1 function? Okay, 1, 1 function definition. 1, 1 means that one pre-image will be having one image. One pre-image will be having one image. This is your 1, 1 function. What about many 1 function? Many 1 is like that. 2 pre-images can have one image. This is your many 1. In here it is very obvious. See, for defining a function, this is your codomain and this is your range. Sorry. This is your domain and codomain. What am I doing? Yeah, this first thing is your domain and this is your codomain, right? Now understand. For 1, 1 and many 1, we should just understand whether this is happening or that is happening. Okay. So clearly, if I talk about f of x equals to x raised to power 4, and if I try to draw the mapping diagram, and if I try to differentiate whether x raised to power 4 is falling under this category or that category, clearly if I put 1, x equals to 1, what do I get? I get function value as 1 raised to power 4, which is 1. Okay, so if I am putting 1, I am getting 1. But what about I am putting minus 1? Don't you think again I will get 1? Because minus 1 raised to power 4 is going to give me the same value. Right? So this is a clear-cut case of many 1 function. Why? Because f of 1 is equals to 1 and f of minus 1 is also 1. So for two values of x, I am getting the same value for y. So this is a many one function. Hence, I can just say clearly that 1 1 wala thing is wrong, 1 1 is wrong. Now the options are either B or D. Now we need to understand whether a function is onto or not onto. Now ma'am, what is onto? How to check for onto? Okay, so onto means that the range, see, what is the definition for onto? How to check for onto? For any onto function, your range and your codomain. Codomain is this, the second set is always codomain, right? So your range and codomain should be equal. Codomain is always given over here. Codomain is this. Codomain means all real values. That means you should get, your range should cover all the values. But if we realize, if we look at the function, don't you think it is so obvious that x raised to power 4 is the output? Do you think that x raised to power 4 will be a negative quantity? No, it is not possible. In fact, x raised to power 4 will always either give you positive or give you 0. That means your f of x, or you can say y, is either 0 or positive, right? So your range is coming out as what? Your range, this is your range. Range is coming out as, range of function y belongs to 0 to infinity. You can never ever get a negative value. That means range and codomain are not equal in this case. So that is why your option, which option is correct? Let me know. Neither 1 1 nor onto. Oh guys, you guys are wrong. Option B, you guys, everybody is wrong in this case. Come on. One marker question, you are doing it wrong. 1 marker question, you are doing it wrong. Very disappointing. What happened? Let me check, huh? Indumati, why did you say B? Indumati thought ki many one is there, but Indumati thought ki there is onto. Okay. Then what about Sejal? Okay. What about, okay. Maybe you are giving answer to the previous problem. Okay. You are giving answer to the previous problem. Sorry guys. Okay. I thought you are giving this as B. Ankush is saying, ma'am, could you please increase the consistency for videos, live session for KCET as I'm eagerly waiting for, okay. Yeah. Sejal, got it. Yes. Sorry guys. Yeah. Also provide PYQ session chapter wise. Yes, Ankush, we will do that. And you must have seen, like daily you will see at least 2 sessions, minimum 2 sessions. Okay. All right. Next question. So 1 marker, I think you will be able to do it. Now there is one more question which will be a 3 marker question. Okay. So this is a 3 marker question which you are seeing. Show that the relation R in the set, this given by R is equals to A comma B, A minus B is even as an equivalence relation. Now you have to understand. Okay. So we need to show that this relation is an equivalence relation. Okay. What is an equivalence relation? Equivalence relation which is the combination of all 3, reflexive, symmetric, transitive. So one by one we have to show that my relation is reflexive, symmetric and transitive. Okay, so 3 marker question. So you will prove reflexive, you will get 1 mark. You will prove transitive, 2 marks. You will prove symmetric, you will get all 3 marks. So this is the format of this question. Okay. So first of all, what I'll be doing is I'll be just writing relation R which is having ordered pair in such a way which fulfills this condition A minus B is even. This is your relation, correct? So what I'll be doing is I'll be talking about what all values will sit inside my relation. Okay, what all ordered pairs will sit inside my relation. Can anybody tell me what all values ordered pairs will sit inside my relation? Okay. So you have set A which is 1, 2, 3, 4, 5. Now just tell me, if I just take first element as 1 and second element as also 1, will it sit inside my relation? Yes. So 1 comma 1 will sit inside my relation. A is 1, B is 1, 1 minus 1, 0, 0 is an even number by the way. Modulus is already there. So 1 comma 1 will satisfy, okay. 2 comma 2 will also satisfy. 3 comma 3 will also satisfy. 4 comma 4 will also satisfy. Then 5 comma 5 will also satisfy. That means clearly my relation is a reflexive relation. Okay, I'll be writing it a little later, but right now I am able to understand. Okay, it is a reflexive, definitely. Okay, so this is sitting. Okay, now what if I take 1 comma 2? It will not work. See, if A is 1 and B is 2, it will not work, because 1 minus 2 is what? 1, which is an odd number. We want the subtraction to become an even number. So that means 1 comma 3 will work. 3 comma 1 will work. Okay. Then 1 comma 3 and 3 comma 1 will work. 1 comma 5 and 5 comma 1 will also work. So 1 comma 5 and 5 comma 1 will also work, right? Then next, 2 comma 4 will work and 4 comma 2 will also work. So clearly that my relation is a symmetric relation as well. Can you see that? My relation is definitely a symmetric relation. Okay. So, yeah. One, 3, 1, 5. And also 3 comma 5 will also sit and 5 comma 3 will also sit. So clearly it is so obvious that R is having 1 comma, clearly 1 comma 1 से लेके 5 comma 5 is belonging to my relation R. This implies relation is a reflexive relation. Okay. So right from here till here, I am getting the reflexive relation. Okay. 1 comma 3, 3 comma 1 is there. 1 comma 5, 5 comma 1, 2 comma 4, 4 comma 2, 3 comma 5, 5 comma 3. So the rest ordered pair starting from 1 comma 3 belongs to R and 3 comma 1 belongs to R. This implies R is symmetric as well. Okay. What about transitive now? See, for transitive, see, 1 comma 3 is there. For transitive, 1 comma 3 is there. And 3 comma 5 is also there. 1 comma 3, 3 comma 5 is there. See, for transitive, 1 comma 3 is there and 3 comma 5 is there. Okay. But can you see 1 comma 5? 1 comma 5 is there or not? Yes, 1 comma 5 is there. Okay. So 1 comma 5 is also there. That means it is a transitive as well. Transitive relation as well. Okay. Getting it? Yes. So hence this is reflexive, symmetric and transitive. All right. Clear? Perfect. Yes, Rohan Kulkarni. Okay, will you be able to do this in your, yeah, Sejal, will you be able to write this down in your board examination? Because see, I know that some of you might be thinking that, ma'am, this is an easy question. What is more important is writing down in your question paper, especially when we are giving most majority of our time in our competitive preparation, just like JEE or KCET exam or COMET examination, we are less likely used to writing the question answers in the examination. So the sessions are all about telling you that how to solve it, number one, and how to write it as well. So understand the idea of writing the question paper as well. And now, yes, this is it. A relation R on the set A is defined as this. Determine whether it is reflexive, symmetric, transitive. Okay. Now this time we don't have to prove. Okay. So whenever the question comes that you have to prove, it is a little bit chill pill question because you don't have to think about it. This time you don't know, you have to determine. So this is not a predictable question. Previously the question was quite predictable. We knew that it is reflexive, symmetric, transitive. If at all we were going in wrong direction, it will be like, no, the question is proved that. But this time you have to determine. So we have to be very careful. 1 to 14, okay. So see, understand. this R is equals to x comma y such that 3x minus y equals to 0. Determine whether it is reflexive. Okay, so first of all, y is equals to 3x. So what I'll be doing is, again, I'll be forming my complete relation based on this condition. Okay, the moment I'll put x equals to 1, I'll get y is equals to 3. X equals to 2, 6. X equals to 3, 9. X equals to 4, 12. That's it, guys. That's it. Because see, set A is still 14. The moment I'll start writing x equals to 5, I'll get y is equals to 15, which is not allowed. It is going beyond our set A. So only 1, 2, 3, 4, 4 ordered pairs are there. Now this question has become pretty simple, pretty obvious that, okay, is this a reflexive relation? Now you tell me. For a relation to be reflexive, there should be 1, 1, 2, 2, okay? So clearly, 1, 1 and 2, 2, all the way up to 14, 14 is not belonging to my relation R. This implies that R is not reflexive, guys, not reflexive. Okay, 1, 1. Now, what about symmetric? Can you see 1, 3 belongs to our first thing? Second thing, 1, 3 belongs to relation R, but 3, 1 does not belong to R. This implies that R is not symmetric as well. Okay, all right. Next. Now, what we can do is R is not symmetric, guys. Okay, then third thing, transitive. Transitive may, see 1, 3 and 3. Can you see this? It is very obvious. 1, 3 and 3, 9 belonging to my relation R, but can you see 1, 9 is missing? It is not there. So R is not transitive as well. Transitive as well. Oops. Yes, Kavya, absolutely. You guys are absolutely right. It is not reflexive, not symmetric, nor transitive. Have a look. Let me know if you guys are having any doubts. Okay. One more question do you want to see on the same reflexive, symmetric, transitive? Okay. One more question. Yes, Kush Mohit, absolutely right. One more question. Okay. Check whether the relation R is defined by this is reflexive or transitive. Okay, again, is reflexive or transitive. Symmetry we don't have to check, only reflexive and transitive. Okay, so see again, and this is defined on relation R. Can you see on relation R? So clearly A comma A for reflexive, check karna hai na. So for reflexive, what happened? For reflexive, tell me, for reflexive, A comma A should belong to R. Okay, that means your in this relation, if I talk about A comma A, I mean if I replace B by A, it should satisfy that condition. Okay, so that means if A comma A, this implies A is less than or equals to A cube. A is less than or equal to A cube. But this is only valid when either A is 0 or A is 1. Correct or not? A is less than or equals to A cube. Is it true for... So, see, this statement is not true. Not true for all values of x belongs to R. See, you must be thinking, ma'am, why are you saying this is not reflexive? Because see, 0, 0 is satisfying. 1, 1 is also satisfying. But you should understand, relation in R, that means all values which are lying on the number line, all real numbers should satisfy this. It is so obvious that half comma half, for example, half comma half does not belong to R. Why? Because half is not less than equals to half cube. It is not true. Not true, right? So that is why this is not reflexive. So this implies that it is not reflexive, guys. Okay. Clear? I guess this is clear to you that okay, now what about transitive? See, this is your relation R, which will have a comma b, and it should satisfy a less than or equals to b cube. Okay. All right. A less than or equal to b cube. Now we are looking for transitive. For transitive, and this is, by the way, defined on, it is very important, defined on set R, defined on all real numbers, right? This is your relation. For transitive, see, yes, Indumati. Now, some people might be a little confused that, ma'am, we don't understand. I mean, how to think about it. See, just one tip from my side whenever you get reflexive symmetric transitive question, okay? So, to prove someone correct, it is very easy. But to prove someone wrong, to prove someone liar, to prove that this person is liar, you just have to catch one lie of his. Yes or no? Yes or no? Just tell me. Suppose I tell you that Ninja Ma'am is a truthful, honest person. But I will every day tell truth. 100 days truth. But one day, if I tell lie, I will become a liar. Are you getting my point? So you just have to catch one lie. Here also, if you proving transitive is not easy. But proving non-transitive is absolutely easy. You just have to bring one case. See, this is not satisfying, not transitive. Are you getting my point? So just think in that direction. How to not prove it transitive. Okay, so for transitive again, just tell me one thing. 9, 3 is belonging to R, yes or no? 9, 3 is belonging to R, yes or no? So let us check, ma'am. Okay, 9, 3, because 9 is less than or equals to 3 cube. Ma'am, yes. It is satisfied the condition. So it is satisfying 9, 3, okay. Now 9, 3 is right here. And now we will talk about 3, 2. Yes. Tell me, 3, 2, is it belonging to your relation? Yes or no? So 3, 2, ma'am, 3 is less than or equals to 2 cube. So 3 is less than or equals to 8. So yes. Ma'am, this is also satisfying, okay. But can you see that 9, 2. See, 9, 3, 3, 2. 9, 2 is belonging to R or not? No, because 9 is not less than or equals to 2 cube. This is a false statement. So again, see, A, B is belonging to R, B, C is belonging to R, but A, C is not belonging to R. Hence, it is non-transitive. So next time, whenever, also in KCET also, and some of you might be preparing for JEE Main also. So if you're preparing for COMET, KCET or even boards also, this is a board question, okay. So you should remember that, think about how to prove it non-transitive. Then you'll start finding that ordered pair which will not satisfy this condition, and you'll be like, oh, this is also satisfying, this is also satisfying, this is also satisfying. And then when your brain becomes tired, you'll be like, oh, I can't find any of the ordered pair which will not satisfy. So maybe it is transitive. So always your brain should work like this, especially when reflexive symmetric transitive, okay. I hope that this is clear. And now let us talk about the next question, which is again 3 marker, or you can say 5 marker question, okay, which says, next question is now reflexive symmetric transitive. So many questions we have done. Now we are not going to do that. We are going to jump directly towards function, okay. And in functions, majority of the time, you will get question from 1, 1 on to inverse of a function, bijective function, okay. So yes. This is your function, let f. F is your function. So this is again codomain. Sorry, this is codomain. And this is your domain. This is your function, be a function, and function is given just like this. Find the inverse of a function. Now you know how to find inverse of a function. If you don't know, let me just tell you, okay? First of all, what you have to do is just write the function 4x upon 3x plus 4. Now next step, fx will be replaced by y. So y will be equals to 4x upon 3x plus 4. Obviously, x is not equals to minus 4 by 3. Now what you have to do is you have to cross multiply. Okay, so just here, can you see your y is completely in terms of x? So you have to now calculate x in terms of y. To calculate inverse, what do you have to do? Calculate x in terms of y. Okay, so how will you do that? By cross multiplication. Okay, ma'am, 3xy plus 4y is equals to 4x. Now, to get the value of x in terms of y, keep the terms related to x together. So this is going to become 3xy minus 4x equals to minus 4y. Yes? Okay. So now I am going to take x common. The moment I take x common, I will get 3y minus 4 is equals to minus 4y. Can you see how beautifully x equal to completely in terms of y? So 4y minus sign, I am going to adjust 4 minus 3y. Yes, this is your x equals to. Clear? Till now it is clear. 4y upon 4 minus 3y. Okay. Now, what you have to, so this is your step number 1. That get the value of x completely in terms of y. Okay. Now what you have to do is interchange x and y. So interchange will happen over here. So y will be equals to 4x upon 4 minus 3x. And this is, by the way, your inverse of f. So this is your f inverse x, which is 4x upon 4 minus 3x. And the domain of your inverse function, is what? Domain is of this is, so here x will not be equal to what? 3 by 4. Sorry, 4 by 3, correct? 4 by 3, because denominator cannot be 0, right? So you have to, so this is your inverse function. This is your final. And just write inverse of f or f inverse x, 4x upon 4 minus 3x. This is how you will mention the inverse of a function, okay? All right. Clear? Yes. Next question, let us check for the next question. This is the next question. Yeah, this is the next question. Show that this function is 1, 1. First of all, show that this function is 1, 1. How to show whether a function is 1, 1 or not? Do you know the method? Please let me know, We have studied at the time of first PUC as well. I have showed it to you. How to check whether a function is 1, 1 or not. Let me just give you a proper stepwise thing that how to check function is 1, 1 or not. So, fx, to check 1, 1, we have to take two values of x. x1, x2 belongs to domain of f. So, this time domain is minus 1 to 1. So, two values of two input values we are selecting, x1 and x2, okay. So, this is your, see, 1, 1. x1 and x2 we have selected. Now, we are checking whether it is 1, 1 or not. So, x1 and x2, now what we are going to do is, we are going to find f of x1. That means the output when x1 is there and output of x2. So, f of x1 and f of x2. And we are going to equate it. Because we want to check whether two different input are giving me same output or different output. That is what we need to check. Yes, Kavya. So, always to check 1, 1, two different inputs have been taken and the outputs have been equated over here. So f of x1 is obviously x1 upon x1 plus 2, and f of x2 is x2 upon x2 plus 2. Cross multiply, x1 x2 plus 2 x1 is equals to x1 x2 plus 2 x2. Clearly we can cancel out x1 x2 and x1 x2. 2 is also cancelled out. This is giving me x1 is equals to x2. Okay, what has just happened? Understand, I tried forcefully to make this function as one. Did you realize? I take two different inputs, and then I thought on two different inputs I will get the same output. See what I did. I have taken two different inputs and I have calculated f of x1 and f of x2, and I have thought both are same only. Okay, both are same only. I tried to forcefully equated them. The moment I equated them, solved them, I realized, okay, inputs are also equal. So for a 1-1 function, if you try to make it many one, it is giving you, no two different inputs, single only. So this is giving me 1-1 vibes. This is a 1-1 function. This function is giving me 1-1 vibes. Okay, so this is a 1-1 function. So first part is done. Now we have to find the inverse of a function. So inverse, so I have already told you. Now I am removing this. Inverse, so I have already told you, steps are fixed. Okay, step number 1. To find the inverse, first of all, make y is equals to x upon x plus 2. Okay, all right. Now yx plus 2y is equals to x. Now you have to take all the values which are having x together and y on a different side. Take x common. So x y minus 1 equals to minus 2y. X is equals to 2y upon 1 minus y. And now you have to interchange x and y. So f inverse x will be equals to 2x upon 1 minus x. This is your inverse function. Okay. All right. Clear? Everything is done. Clear? And now we are having the last question, which will be 5-marker question. Are we ready for it? Are we ready for 5-marker question, guys? Okay. All right. So now, actually 2 more questions are left. 2 are left. Okay. One I will do, one I will give homework. This is the question which says that consider f. Now understand, I'll rewrite it for you. F is such that r plus 2 minus 5 to infinity. Now understand, this will play a huge role in understanding the function. So your domain, that means your input, is positive set of real numbers, r plus. And this is your range of the function. Fx is given as a quadratic equation, which is 9x square plus 6x minus 5. Show that f is invertible with this. Show that your function is invertible. Negative symbol is missing, you are saying. No, I have, oh yes, sorry. I tried to, yes, this is 2x upon x minus 1. 2x upon x minus 1. Now I guess it's correct. Yes, Kavya, thank you. Thank you for mentioning. Yes. Now this is something which is a little bit on a trickier side. Y equals to x square plus 6x minus 5. This is your function, right? Now first of all, we have to show that my function is invertible and we have to find inverse. Okay, so this is a 5-marker question. You have to understand that you have to write everything in this question, whatever they are asking. First of all, we need to check whether your, sorry, this is 9. Yeah, you need to check whether, show that f is invertible. So we need to write, for a function to be invertible, for a function to be invertible, for a function to be invertible, okay, for a function to be invertible, function should be 1 1 and onto. So first thing is, you can't jump and find inverse of a function. First thing is you will find whether function is 1, 1 or not. We have the same method, okay? Now check for 1, 1. We will check for 1, 1. So f of x1 is equals to f of x2 for x1 comma x2 belongs to R plus. Now understand, here the domain is real values, positive real values. So we need to check for this. F of x1 is equals to f of x2. So again, I'll take another slide. So f of x1 will be 9x1 square plus 6x1 minus 5 is equals to 9x2 square plus 6x2 minus 5. This is your f of x1. This is your f of x2, correct? Tell me. Okay. Minus 5 cancel. This and this I can shift everything towards left hand side, right? So 9x1 square minus 9x2 square plus 6x1 minus 6x2 equals to 0. So 9x1 minus x2, x1 plus x2 plus 6 x1 minus x2 equals to 0. Clear? x1 minus x2 I can take common. So what I'll be getting is 9x1 plus x2 plus 6 equals to 0. This is x1 equals to x2 and this will be what? 3 2s are 3 3s are. So 3x1 plus 3x2 is equals to minus 2. Okay. See, over here 3x1 is equals to minus 3x2 minus 2. Now understand. See, x1 is equals to x2. If this was the case, I would have assumed that my function is what? 1, 1. But what about this? I am getting two different inputs. Now understand. This expression is invalid or this is a false expression. Why? Understand. In the beginning, we decided that x1 and x2 are both positive real numbers because x1 and x2 are belonging to, let me go back. See, x1 and x2 are positive. But from here, can you see that if x1 is positive, so that means LHS is positive. 3x1 is a positive quantity. If x2 is positive, okay, so minus 3x2 will be a negative number and more minus 2. So this right hand side, can you see this expression suggests that LHS is positive because x1 is positive. RHS is a negative quantity. Why? Because x2 is again positive. You put any positive number in place of x2, you multiply minus 3, it will become negative. Negative and negative, if you combine them together, you will get a negative quantity. That's why your RHS is negative, LHS is positive. That means this thing cannot be equal, can never be equal because of this positive thing. So that means this is not valid. So I solved f of x1 is equals to f of x2. I tried that x1 and x2 are two different quantities and both are giving me same output. But the expression is saying no, hey, hello, you are delulu. x1 and x2 are equal. Yes, Kavya, it is 1, 1. Now you are getting it. This question is giving me 1, 1 vibes again. And obviously, see, the question was we have to show that it is invertible. It is given. We don't have to apply your brains. You have to prove it. If you're not able to prove it, you are wrong, dude. Question is correct. So 1, 1 to have proved. What about onto? Okay, so now how to prove onto? Now understand, onto means we have to prove that the range of this function is minus 5 to infinity. Okay, so for that what we will do is how to find range. So now I will again, to find onto and invertible will go together hand in hand. Okay, inverse of a function together. Okay, so we will prove it onto and we will find inverse also together. So y is equals to, understand, 9x square plus 6x minus 5 is given. Okay. where your function is having r plus 2 minus 5 to infinity. Now you are looking for the range of this. How to find range, first of all? So understand how to find your range. So you will, okay, so how to find inverse? Remember I told you how to find inverse? You want the value of x completely in terms of y, but right now it is a quadratic. How to get the value of x when there is a quadratic? So to find the value of x whenever you get quadratic, remember the quadratic formula, right? So suppose you are having this quadratic equation ax square plus bx plus c equals to 0. So x will be equals to minus b plus minus square root of b square minus 4ac upon 2a. Remember this quadratic formula? So I'll use this quadratic formula to find the value of x completely in terms of y. Watch me doing this. So y I will be shifting towards the right hand side. This is the technique. You have to learn this technique, guys. Is equals to 0. Clear? Now again, this is ax square bx and this is the constant. This is the constant. Minus 5 plus y is the constant. Now apply the formula. X equals to minus 6 plus minus square root of b square. 36 minus 4. What is a? 9. What is c? This is 5 plus y with a negative sign upon 2 into 9, that is 18. So x will be equals to, further let's solve it, 6 plus 9. 36 can come out. Can you see? 36, root 36 we can take out. It will become 6. Root 36 is gone. 1 plus 5 plus y upon 18. I can cancel some things right here. Okay. 6 ones are 6, 6 twos are 12, 6 threes are 18. So this is going to become what? Minus 1 plus minus square root of 6 plus y upon 3 is your x. Okay. So now you are getting two values of x. Hold on, this is not allowed. Function doesn't work like this. Function can never have two outputs, okay, based on one input. So we have to think about it. There are two signs, positive or negative, okay. So let me just say x is equals to minus 1 plus minus square root 1 plus 6, okay, 6 plus y upon 3, correct? Let me just go back. Let me get back to the question. Let us see. Oh, can you see that one of the expression is written over here? Root y plus 6 minus 1 by 3. So we are very close to our answer. Right here, we just have to, so this is your f inverse y. Basically, this x is what? F inverse y. F inverse y is minus 1. So there are two values. See. So suppose there are two values. See, minus 1 minus square root 6 plus y upon 3. Can you see x is this, which is a complete negative quantity rejected because x is never negative. If you go back to the question, you will realize that domain is r plus, okay. Your domain, your input is a positive quantity. Can you see minus 1 minus 6 root 6 plus y? Obviously it is a negative quantity. We don't want this. X can never be negative. Another thing, we will accept it, plus 1. So can you see this is a positive quantity, okay, positive quantity. It will be accepted. So this is root of 6 plus y minus 1 upon 3. So this is the inverse, and at the same time you have to prove that this is an onto. We have still not commented on the onto part of it. So now onto. So this is what? This is the value of x in terms of y you have got, and whenever you see square root, you will realize the expression inside the square root 6 plus y should always be equal to, should always be non-negative. We can never have an expression inside square root, a negative expression. We can never do that. 6 plus y, can you think about 6 plus y being negative? Never. So from here you will get the range of y. So y is greater than or equals to minus 6 you are getting, and y is greater than or equals to minus 6. So if you go back, this is your function. So minus 5 to infinity, what you are getting is minus 6 to infinity. So y belongs to minus 6 to infinity. Clearly, this is your range. Okay. This is your range. And what about your codomain? codomain is -5 to infinity, right? So clearly, although right now you can't see that they are equal, but can you see range? See, codomain will always be superset. Range will always be the smaller set. So range should be subset of codomain, which is happening, okay, which is happening right here. We can just remove that -6 to -5 value. It is satisfying. So yes, this is an onto function. Onto function. So yes, onto, this is the inverse and onto, both we have calculated at the same time. Okay. Clear? Have a look. Let me know if you guys are having any doubt. The next question is going to be a homework question, preferably. But if you guys tell me that, ma'am, do it right here, I can do that for you. So the next question is this, which says that fx is equals to 4. By the way, 5 marker question, obviously it will be the lengthy question, okay? Fx is given as 4x plus 3 upon 6x minus 4. This is your function. And obviously denominator will not be equal to 0. So that is why 6x minus 4 not equals to 0 will give you x not equals to 2 by 3. So this is your function. We need to show that f of x is equals to x. Okay, and what is the inverse of f? Okay, so first of all, we need to talk about the composite function. F of x, we need to show that this is x. Okay, and we need to calculate the inverse. Okay, so see, whenever you see f of x is x, that simply means that fx and f inverse x are equal. That means a function and its inverse are equal. So the moment you start calculating inverse of this function, you will realize that both are coming same. So f inverse x, the final result you will be calculating, it will be 4x plus 3 upon 6x minus 4 only. You will get the same result. Are you getting my point? So this is DIY, try it yourself, and if you guys face any doubts, I'll share the solution of this, okay? Do you want to try? Yes? Give me a big thumbs up if you are up for it. So this is the last question, okay? And also before leaving, yes, Kushmohit, thank you so much. Yes, Indumati, I guess you'll be able to try. Before I leave, just one request, because some students were texting me on my Telegram that this is what is coming in upcoming examination. Within a week we have exam. So what board session you want to see next in mathematics, please comment, so that next session I will bring that PYQ session only, okay? All right.